My presentation is on the topic devices and DDA algorithm with numericals. The topics that we'll cover are definition of display devices, how we moved from cathode ray devices to OLEDs, the transformation from that generation to this generation. Then we'll see types of display devices, working of modern display devices, introduction to DDA algorithms we learn with numerical. The objectives will be to understand the importance of display devices in computer graphics, to study various types of display technologies that will be cathode ray devices, LCD, LED and OLEDs, then to learn DDA algorithms step by step, and again we will be learning it with the help of a numerical. Introduction to display devices. Now, why do we need display devices? Display devices act as an interface between the users and the animation of the graphics. Without display devices, we will not be able to see the graphics. Display devices are output hardware components that present visual information to users. They convert electronic signals from the computer into images, videos, and text. As I told, they help us interact with digital systems visually. They are essential in computers, televisions, laptops, projectors to see the display. What is the need of display devices? For example, in gaming, there would be no significance of a game without a display device. The user will not be able to interact. They provide a visual interface between user and computer systems, as we've seen earlier. They help in understanding graphical and multimedia content easily, as it acts as an interface between the graphic content and the users. We are able to understand about the graphic content more. It is essential for education, entertainment, gaming, designing applications. It improves communication of information in a digital environment. Now, these are the main types of display devices. Earlier we used to use the cathode ray tube that was very big in size also. Then came the LCD that was very thin as compared to the cathode ray tube. Then furthermore LED came, and then now the latest one is OLED and the plasma display. We'll be learning about them in the later slides. So the earliest form was cathode ray tube. This was very large, big in size. It was traditional bulky monitor technology. It used electron beam to hit phosphorus screen, and it produced image by illuminating pixels. This is a diagram that represents the cathode ray tube, and the advantages were that it had better color quality and good refresh rate, but it also had disadvantages as the size was very large and it used to consume a lot of energy. Power consumption was very large. Then came LCD that was very thin as compared to the cathode ray tube. This was thin in flat display panel. It used liquid crystals to block and pass light. It was very common in laptops and TVs. So one of the major advantages would be that we could easily carry the laptops, as the screen was very thin in size, and TVs were also very lightweighted. It had one more major advantage would be that it consumed a lot more less power than the cathode ray tubes. It was very lightweight. Now further on, LEDs to existence. LED is an advanced version of LCD technology. It uses LED backlighting instead of fluorescent lights. It produces brighter images with better contrast, and it had more energy efficiency, and it was durable than LCDs. Again, a better form of LEDs came into existence in the market, that is the OLED display, organic light emitting diode. It used self-lighting organic compounds for each pixel. No backlight was required for OLED displays. It provides with deeper blacks and vibrant colors. It is used in premium smartphones and TVs. The color quality kept on getting better and better, and there's a latest addition to it, that is plasma screens. But these are the major display devices in the market. Is a comparison table of those 4 display devices. As we can see, the OLEDs have the most excellent quality, whereas it is higher in cost, again because of its excellent quality and the efficiency to consume less power. The CRTs were low in cost, but they consumed a lot of power, and the quality was also medium. You can see the comparison table regarding the quality, cost and power consumption. LEDs had medium cost, they consumed low power and were good in qualities. Then LEDs were even better in qualities with medium cost and very low power consumption. Then OLEDs are excellent in quality with high cost and low power consumption. Now this is an introduction to the DDA algorithms. What exactly is DDA algorithms? For example, in Paint, when we draw a line, how exactly is it drawn? A straight line. DDA algorithms are very important in the making of straight lines. What DDA stands for is Digital Differential Analyzer. It is a line drawing algorithm used in computer graphics. It calculates intermediate points between 2 endpoints, and these points are plotted to form a straight line on the screen. Now furthermore, we'll see how exactly it plots a straight line using a formula with the help of a numerical. But firstly, we'll see the purpose of the DDA algorithm. Now, why do we use DDA algorithm? Because it helps us draw straight lines digitally in raster graphics. It simplifies mathematical calculation for line generation, and it is used when coordinates of endpoints are known. It converts continuous line into discrete pixel positions. We'll be able to understand this with the help of a numerical, how we use 2 endpoints in order to generate a line. We have 2 points x and y. Now we find the difference of the 2 points dx and dy. For example, we have x to x1 and y to y1. So we find x2 minus x1 and y2 minus y1, that is dx and dy. Now if dx is greater than dy, then this is the formula to find the number of steps. We will find the maximum of the 2. For example, the maximum of the 2 is 6, so the total number of steps would be 6. Now the next value of x would be incremented by using x increment. It has its own formula. X increment would be dx by number of steps, and y increment would be dy by number of steps. So x next would be x plus x increment, and y next would be y plus y increment. Now DDA algorithm steps are as follows. We find the inputs. We are given the starting and ending points. We calculate dx and dy. We find the number of steps. We calculate increments and plot points until endpoint is reached. Now this is a numerical example. We are given 2 points, 2, 3 and 8, 6. Now we have to use DDA algorithm in order to plot a line between them. Now dx would be the difference between the 2 values of x, that is x2 and x1. The 2 values of x are 8 and 2, so dx would be 8 minus 2, that is 6. Now dy will be the difference between 2 values of y, that is y2 minus y1. The 2 values of y are 6 and 3, so dy will be 6 minus 3, that is 3. Now number of steps is the maximum of the 2 values dx and dy, which is 6. So there are total number of 6 steps we'll be using in this question. Now step 2 is find increments. So now we'll get to know by how much will we increment x and by how much will we increment y. That is 6 by 6, that is 1. So we'll increment x by 1 and we'll increment y by 0.5. we'll be adding these numbers to the current values of x and y in order to get the next value of x and y. This is a chart, this is a table that has x incremented values and y's incremented values, and the total number of steps are 6, as we can see. The advantages in applications are that it is easy to implement, it has simple calculations, it is good for beginners. The applications are CAD software, games, drawing software. I'd like to conclude that display devices are essential output hardware in computers. Different display technologies provide different benefits. The interface is very useful in order to understand the graphics. DDA algorithm helps in digital line generation. It makes the line generation easier. It is a fundamental concept in computer graphics. Thank you.